Hello, welcome to the next segment of our cooling system. Now this is a segment that we're going to go through theory and operation, and I'm going to simplify it as much as I can. But the main thing is to possibly take notes or possibly review this as many times as you can until you understand it. In the cooling system, I just want to go over the basic idea of how it works, starting with this diagram up here. What we have in a basic cooling system is a radiator. The radiator has coolant that runs down these tubes here, and the coolant is inside these tubes is taken away through airflow through these little coolant zigzags we call air passages. Now we have the nozzle or the cap, the filler place of the radiator, and we have the top radiator hose. In this configuration here, this is where the pressurized, now keep note of this, pressurized part of the coolant comes out. The pressurized part comes across here and goes down these tubes, and it enters the suction side, where this suction side has been cooled. So to keep this in mind, you have to realize this is pressure, this is suction. This hose is pressurized, but if this hose does not have reinforcing wire inside of it or ribbing inside of it, it can collapse and stop the flow of coolant that is going to cool the engine. So keep those little tidbits of information in mind. Here we have the reserve or the recovery tank. It's called an expansion tank. And what happens is when the radiator heats up, the vapor goes down this tube and it liquefies into this recovery system. When the radiator cools down, it creates a suction in the radiator and it pulls the liquid from here back into the radiator. So it's always filling the radiator, or it's always extracting or expunging radiator coolant out into here. Now, you're going to notice something here. We have the heater core. Now, this is the most important part. The heater core is directly connected to the engine, and it does not need a thermostat, which is located here. Now, let me tell you what the thermostat does in a minute. Just know that the thermostat is simply a valve that automatically opens and closes somewhere between 182 to 200 degrees Fahrenheit and allows water to flow to the radiator. And that is the only time coolant flows to the radiator, is when the thermostat is open. But here, the heater core is always being heated on many systems. Now, some systems work differently. This is a standard system. It has a heater control valve here and a heater core, which is a mini radiator, just like this, only in miniature, with a fan that blows cold air past these heated tubes and produces heat inside the passenger compartment. Now, I want to start focusing on water jackets, but for now, I'd like you to see that the water jackets are on the outside of the combustion chamber where all the explosions happen. It produces heat anywhere from 700 degrees. It could be possible clear up to 2,500 degrees. And that heat has got to be pulled away so the piston's rings do not melt or the piston does not get damaged. So the heat is pulled away via the transfer of heat through the metal, and then the water picks up the heat that's in this metal and takes it to the radiator. Okay, when we look at the expansion tank or the recovery tank, we see that this is not a pressurized recovery tank. It is only relying on the radiator cap, allowing pressure to be released and put into the recovery tank. Then it flows back into the radiator, or it goes back directly into the water pump or the engine block. Remember, this right here is our thermostat. You can kind of see an X-ray view of it here, and I'll show you how it works in a moment. But we can kind of see that the water pump is pulling coolant from the radiator through the pump and to the water jackets first. So that is where that coolant is going, as well as the heater core. Again, it is not reliant on the thermostat. You can see the coolant going to the water jackets through here. It's pretty explanatory. As you see the water jackets and the coolant pulling heat away from each of the cylinders. This one's under fire, this one's under suction, this one's on exhaust. We'll go through the 4 cycles at another time. Okay, so let's go through first the theory and the reasons why we have a cooling system. First off, the application. The application is to cool effectively under all operating temperatures and conditions. This is where we left air-cooled motors and went to water-cooled motors because of the effectiveness of the coolant pulling heat away from the combustion chamber. That is why it cools effectively. The other reason, or application, is to allow the engines to operate under higher compression temperatures. Higher compression engines cannot be air-cooled. There is a point when there's so much heat produced by high compression, such as a diesel engine, that we need water-cooled engines or liquid-cooled engines to accommodate the high heats generated from high compression. So keep in mind, higher compression equals higher heat. Therefore, air-cooled cannot accommodate that particular engine configuration. On the third reason is we have to keep engines reliably cool at all times under all altitudes. I can take a motorcycle that's air-cooled only up to a certain amount of height, and then it becomes ineffectively efficient because it cannot cool very well. However, I can take a liquid-cooled engine up much higher with much higher compression, such as an airplane, and I can cool it more effectively because I can keep the compression high, and the higher in altitude I get, the more I maintain my horsepower. The other part is to cool engines at all locations of the engine parts. In other words, from the heads to the block to the water pump, throughout the entire engine, it keeps the engine temperatures consistently the same temperature. The other and last reason is to produce heat inside the passenger compartment. So that's the theory and application and reasons for the cooling system to be liquid. When we get into the operation, we start with the parts and the function. The coolant, of course, is the medium that pulls heat away from all the parts needed inside the engine, the combustion chamber, the heads, the water pump, all of these things that need to have heat moved away from it is done through the liquid coolant. The water pump is the part that creates the flow inside the engine. In other words, the flow of coolant inside the coolant passages inside the engine. The thermostat, it regulates the temperature inside the engine and keeps it consistently at a consistent temperature. It might be 185, 186, 220 degrees Fahrenheit, but it keeps it consistently the same temperature by opening and closing as it cools, as it heats up. As it heats up, it opens. As it cools, it closes. There are belts and hoses as part of the routing system for the coolant. There are freeze plugs that are designed to pop out and allow the coolant to drain out of the engine so the engine doesn't crack, or the block or the casting or the cylinders don't crack. Water jackets obviously are used to cool the cylinders and transmit that heat that's generated inside the combustion chambers, that's anywhere from 700 to 2500 degrees, back to the radiator. Here I have 3 parts. This one, belts and hoses. This one has the fan, the radiator, and the fan shroud. The fan pulls air through the radiator, and the fan shroud directs the air that is being cooled through to the engine to focus more condensed airflow around the engine itself rather than the whole engine compartment. Then we have the radiator cap, which is our pressure relief valve that allows pressure to go out, steam to get turned into water and go into the recovery system and go back again to the radiator. And then we have the heater core and the fan and the heater control. 3 parts: the heater core and the fan and the heater control. All 3 parts are used to heat the passenger compartment. And last, and I wrote this down last, is provide ventilation. Ventilation, in other words, directing the heat in and about the passenger compartment. So we put venting or ventilation for the passenger compartment, but the main portion of that venting, the main purpose, is not just to heat the compartment, but to defrost your windshield as a safety feature. Next, we come into our testing. Testing skills that you will be performing are pressure testing the radiator cap. That's our pressure control valve. The pressure pop-off, the pressure blow-off valve. The cap keeps the pressure at a certain level. When it reaches too high a level, it vents out that extra pressure. There's the freeze and the boil point test, testing how good we are below zero, we're protected, and the boiling point, at which point the antifreeze mixed with water will boil. Keep in mind, the more antifreeze we put with the water, we raise the boiling point. Here at 5,500 feet, water boils at 195 degrees. When we add coolant to it, it goes clear up to 200 degrees and higher with the addition of coolant. We also check for the pH, which is like the acidity or basicity of the water, and the water hardness, which is in the calcium. This is what plugs up your radiator. This is what eats up the radiator, the head gaskets, the heater core, even parts of the freeze plugs and engine blocks. All comes down into hard water. Then we test for metal contamination. And here we're going to be looking at pulling a sample out of the radiator to look at the debris, if it's cloudy, if it's dirty looking, what the color looks like. It's a visual look at what is the coolant, the way it looks like inside. The rule of thumb is simple. If you cannot see inside the radiator through the coolant and look at the coolant passages, it's too dirty. Temperature and operating control conditions. Okay, so is the thermostat operating properly? Is it opening and closing at the right time? Is the control of the thermostat and the conditions it's under, like heavy loading, going up a hill, under heavy demanding conditions, is that temperature staying consistent at that degree? Next comes restrictions and flow. Next comes when I talk about restrictions and flow, what I'm talking about is the radiator plugged? Is there a suction hose that is collapsed and stopping the flow of fluid? Is there a water pump that has got air in it that cannot pump coolant because it cannot move air? And we have leaks. Any kind of leaks, either internally or externally, need to be addressed inside the coolant system. And we also are looking at water pump function. Starting with the belt tension. Is the belt tight enough to turn the pump? Does the pump have any leaks? Is the bearing in the pump gone out? These are the types of testing that every one of my students are going to be required to do. Again, pressure testing, freeze point, boiling point testing, contamination of metal, debris, and color, temperature and operating control conditions. Is that temperature consistent throughout the engine? Restriction and the flow of coolant. Is it flowing because the belt's tight enough? Because the water pump has no air in it? Because the water pump is working properly? Is the radiator plugged? Do we have any internal, external leaks? What about our water pump function? How is it functioning? Is the belt too loose? Does the pump itself have leaks? Is the bearing going out in the pump? These are the tests that you will be testing on a typical water pump, cooling system from top to bottom. So let's take a look at the real parts. These are used old parts. I don't like to see perfect parts. When I do a video, I like to put real world into the real instructions. So let's go through some real world situations. We talked about restrictions. The other restriction we did not talk about is contamination and dirt.
getting into these zigzag fins. Let's take a look at the contamination. Take a look. As you see the dirt, there is contamination also, which restricts our airflow. Real world stuff, as you can see, contamination. What we have is the pressure side here on top and the suction side here. When we look at the radiator, what we see are the cooling tubes that go along where the water goes down or the coolant goes down to be cooled by the time it reaches this point here. What happened here? A student pulled too hard on this radiator hose that was up here like this, pulled too hard and pulled the top part of the plastic off because the radiator was under pressure. But let's move on. So what we do have is the part of the filler part of the radiator that has the radiator cap that is also a pressure control valve as well. This is another example of a thermostat that is built in to a thermostat housing. As you can see, the thermostat and the housing are one and the same assembly. However, you might find that a thermostat housing and a thermostat are separate. But what we see here in the real world is we see that we have a thermostat that is stuck open. Take a look. If you can see the light coming through there, you can see that that thermostat is literally stuck open. It's stuck open and it never gets hot enough in the wintertime to heat the passenger compartment. Again, this is the part that goes towards the motor block. This is the part that goes towards the radiator, this direction, and it mounts in here like that and goes to the radiator. From there, we have the heater core. This is off a truck. This is a brand new heater core, and these are the types of hoses that go to the heater core. So let's take a look at what goes in over here to the engine. Follow me over here. So what we really have here, if we can see this, is that the heater core, I want to demonstrate, is always directly connected to the motor. There is no thermostat. I'm just doing this to show you how direct. It's not hooked up this way, but it is routed this way, and it is directly hooked up to the engine. Now we have a valve, an on-off valve that allows coolant to go through here at certain rates, either half throttle or full throttle, or we call it half closed or open closed. And that's how we regulate whether it's hot, warm, or cool by a valve that goes this way. That's called the control valve. We'll get into that a little bit more detail in a minute. But I wanted to show you this is where the heater core is hooked up. Now, let's go through the water passages back at the engine block real quick. Water pump, as we see it over here, I want to show you some water pumps. This is the actual water pump that goes to the motor I'm demonstrating right now. So here you see the inside of the water pump. There is coolant going in and coolant going out. Coolant going in goes in here. It's picked up through the impeller shaft that looks like this on the other side. And it goes out here, right here, and it also goes out, and I'll show you the ports inside the engine block. Here we have the fan bolted to the pump itself. The bearing is here, right there. The suction part is here. And this is the bypass hose right here. In other words, it allows the coolant to run around in the engine block until the thermostat opens up. Let's go take a look at what's going on. We'll go over to the engine block. Ready? Moving to the engine block, we see the outgoing hole here, the outgoing portion here. It bolts right to here like that. And it starts pushing coolant that has been cooled through the radiator, through this hole. And that takes care of this side of the motor, and this hole here that takes care of this side of the motor. Again, it bolts in like that. And this is our bypass that allows it to run around and around in the motor. Now, let's take a look at the water jackets themselves. I'll highlight these water jackets, and in this you'll be able to see how these water jackets work. here is a water jacket, here is a water jacket. Remember, it goes in through here and it goes across and around the cylinders. If you guys can all see that. Cut. Look at this, guys. Here we go. As you can see the light going in here, and you can actually see where the coolant comes out and around the cylinders. Cooling the cylinders here, and it goes through all of these water jacket passages this way. So it goes through here. That's the journey. Starts here from the bottom of the water radiator to the water pump, through the cooling water jackets, in and around the cylinders, and from there we go to the heads. So now it's going to travel up and through the water passages here. So we got here, 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 and all of these are water passages coming straight and directly up through the water jackets. So we can actually see every one of these water jacket passageways that come out of this part here. That's the exit. That is the exit. And from those two exit points into the intake manifold, which is here and here. Again, this one going directly to the heater core. This also heats up the manifold to heat up the fuel to make it combust more efficiently. It has a dual purpose. This is called the intake manifold here. Okay, so you can see that the air and fuel come in through here, 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 here. Exhaust goes through here to help heat up the fuel, and the water jackets coming up from the heads through here and through here, coming in, they connect here and connect here. And at the end of the day, what happens is it goes to the radiator. There's my thermostat, and there's my thermostat housing. That should make it explanatory enough for you to understand how the cooling system routing goes.